Hi students. Today we'll be factoring special cases, sums and differences, and the difference of squares. Let's begin with a warm-up. Go ahead and pause the screen and complete the warm-up. Now that the warm-up's complete, let's go ahead and get the answers to it together. If you look at the first one, I notice that 6, 9, and 3 all have a common factor of 3, and each of them has an x. So I'm going to pull out a 3x, the GCD or GCF of these terms. Now it looks like this. Now I can go ahead and start by putting the 2x squared here. First term goes in the first box. Last term, -2, goes in the last box. The middle term, 3x, goes on the bottom. And -4x squared, the product of the first and last terms, goes up here. To get -4, I can multiply 1x times 4x, and I'll make that negative. When they add them together, you get 3x. So 1x and -4x. Getting the outside of the box, I can put 2x here and x here to give me 2x squared. X times 1 is 1x. 2x times -2 is 2x. Go ahead and put these in parentheses, so this is 2x plus 1 and x minus 2. Don't forget that you factored 3x out from the beginning, so put that here, and this is your final answer. Looking at number 2, we can check first to see if there's a common factor between 4, 44, and 121, which there's not. So we'll put 4b squared in the first box, and we'll put 121 in the last box. 44b, the middle term, the sum, goes in the bottom part of the x here. And when I multiply these two numbers, I can put that in the top part here. And that's 484b squared. Notice these numbers are really large, and I'm trying to find a shortcut instead of having to do the box and the diamond here. I'll continue, and hopefully we'll be able to find a shortcut instead of using the box and the x if I can go straight into parentheses. We'll look at that today. Go ahead and finish here. So this will be 22b and 22b here. And when you multiply, you get 484. When you add, you get 44b. That's 22b and 22b. Now the outside of the box, I can put 2b and 2b here. That'll give me 4b squared, 11 here, and 11 here. 2b plus 11 and 2b plus 11. They happen to be exactly the same. Notice why it became that from what we started with. Let's go ahead and get into the lesson for today. Factoring special sums is the first part. We can start this one. It should look really familiar to the warm-up. Remember that we're trying to get this into parentheses to make this a product. You can think in your head, if I don't use the box and the x at all, is there a way I can think about this by just thinking about FOIL? So for example, 16n squared, I know that this will be 4n and 4n, because 4n times 4n is 16n squared. Now we need to think about what this last term will be. The last term, if you look at 49, that happens to be a perfect square. So I know 49 is 7 times 7. Put a plus sign, and I'm actually done here. Way quicker than having to complete the box and the x for it. If you want to check, you can FOIL this out and check that when we do this, we end up getting exactly what we started with. If you want to double check and make sure we did the correct part here, I'll show you. So we can put 16n squared and 49. That's the first and the last terms in the boxes. The middle, 56n, is the sum, and that goes here. Now doing the top part, having to multiply this out, this ends up being 784n squared, which is why this is really hard to think of or having to do this calculation here. So I'm trying to help you see the shortcut when we have perfect squares, the 16 and the 49. I'll go ahead and finish the x, so this is 28n, 28n. Fill it into your boxes, 28n and 28n. The outside is 4n and 4n, 7 and 7. This is exactly what we got from the very beginning, recognizing that 16 and 49 are both perfect squares. Let's look at a different special case. This is called the difference of two squares. Go ahead and copy this in your notebook. We'll go ahead and start with this example here. So notice in this example, it's actually missing a term from what we've seen before. So I'm going to rewrite this as x squared plus 0x minus 36. The middle term is actually missing. You can see there's no spot for it here. So to hold the place, I'm just going to put 0x so that I can complete the box and the x here. So the first term, x squared, goes in the first box. The last term, negative 36, goes in the one diagonal from it. The middle term, which there is no middle term, it's empty, is 0x. And when I multiply the first and the last, I get negative 36x squared. To get negative 36, that's 6x and 6x, and I'll make one of them negative so that when I add those together, I get 0. So this is 6x and negative 6x. I end up getting x, and x would give me x squared. X times 6 is 6x. X times negative 6 is negative 6x. Finally, in parentheses, this is x plus 6, x minus 6. And this is my final answer, the factored form of what we started with. Now notice that 36 is a perfect square. So this just became a positive 6 and a negative 6 here. Following the rule of difference of two squares, I can generalize and do this on the next two. So looking at the second example, let me switch to a different color. 3c squared minus 75. Before I begin, I notice that 3 and 75 both have a common factor of 3. So I'm going to factor that out first. Taking a 3 out, this leaves me with c squared. 75 divided by 3 is 25. Now I could do the box and the x here, but I notice that 25 is a perfect square. So let me bring this 3 down, and now I'll open up two sets of parentheses. I can put a c and a c. C times c would give me c squared. 25 is 5 times 5. I'll put 1 as plus and 1 as minus. 5 times negative 5 is negative 25. And the middle terms and the outer terms would cancel out and leave us with what we started with. The last one, 9v squared minus 4. There's no common factors between 9 and 4, so I'll go ahead and start by opening up my parentheses. I notice that 9 and 4 are both perfect squares. 9 is 3 times 3, and I need v's here. 4 is 2 times 2, so I'll put 2's here. A plus and a minus. And I'll complete this one by foiling it out so you can see that what we get here is actually what we started with. First, that's 9v squared. Outer is minus 6v. Inner, plus 6v. And last, negative 4. Negative 6v plus 6v go away, so I'm left with 9v squared minus 4. Just to double check. And again, my final answer on this one, the factored form, is right here. Go ahead and try these examples here, and I'll see you guys in class tomorrow.